Hi everyone, so this is part 2 of our bonding video for lesson 1, and we're going to get into just like the main notes. So in part 1 you were looking at the physical and chemical properties of ionic versus covalent compounds and how to identify what makes something ionic and what makes something covalent. And so now we're going to get into that in a little more detail. So the first thing that we need to talk about is when we're talking about bonding, what is a chemical bond? Okay, so a chemical bond is an attractive force. Okay, I need to decrease the size of this pen. Give me one moment. Okay, it is an attractive force between atoms or ions. Okay, so between either atoms or ions that binds them together as a unit. And so these atoms are going to form bonds in order to decrease the potential energy, okay, which the potential energy is in the atom, it's stored in those chemical bonds, and they want to increase stability. Remember, this is due to the number of valence electrons, right? We talked about the octet rule in Unit 2 and Unit 3, okay? How all atoms want to be similar to the noble gases, they want to be stable, that sort of thing. So the two ways that they're going to do it is through covalent bonding, and this is when valence electrons are shared between the two atoms, or an ionic bond, in which case those valence electrons are completely transferred. So covalent bonds share electrons, but ionic bonds transfer the valence electrons. And when they do, this forms positive and negatively charged ions that are held together by attractive forces. Okay, so remember, positive and negative are attracted to one another. So it creates this attractive force. Now, with covalent bonds, okay, which remember are sharing electrons, there are two types of covalent bonds. There's polar covalent, where there is an unequal attraction for the shared electrons, which creates partially charged poles. Okay, so it creates partially charged poles. Now, poles, I just mean like the end of each atom. And so what that means is that there is an asymmetrical or unsymmetrical electron density. So what that means is if we were to draw what a polar covalent bond looks like, is you're going to have something with a partial positive charge. I actually need to make that pen a little smaller as well. You're going to have something with a partial positive charge and something with a partial negative charge. But if my space represents the electrons taken up, it's uneven. You can see that the circle area around the negative part is bigger than what's around the positive, okay? And so the electrons that are being shared are kind of in the middle there, okay? They're moving around. Now, that symbol, the delta with the positive and the delta with the negative, is the symbol for partially negative and partially positive. So it's not a full positive or negative charge, it's only partly. Now, when you have a nonpolar covalent bond, this is when electrons are shared equally. And so when you do that, it creates a symmetrical electron density. So in this case, if you have the electrons that are being shared, okay, then the electron density is equally distributed around them, okay? So that bond, this is kind of what an electron density bond map would look like for those two types. So let's actually then compare all three. So we have ionic bonds, polar covalent bonds, and nonpolar covalent bonds. In the ionic bond, so let's say we have sodium chloride, NaCl. What happens is if we have sodium here, and we have chlorine here. And actually, chlorine is bigger than sodium, so I'm gonna draw that slightly bigger. Okay, what happens is sodium as a metal is going to give its valence electron to chlorine. Okay, and so that means that sodium will have a +1 charge and chlorine will have a -1 charge. So the valence electron gets transferred. Okay, because remember, sodium has 1 valence electron, chlorine has 7. So this is when we have the transfer of 1 or more electrons. Okay. And so these have a full charge. There's no partially charged. These are fully charged ions that are attracted. Okay, so the sodium, which is positive, and the chlorine, which is negative, attract each other, and that forms the bond. So this positive and negative charge is attracted to one another. Okay, and so if we look at a polar covalent bond, so for example, hydrochloric acid, okay, when you have hydrogen and you have chlorine, the atoms are bonded, okay, and these electrons that are being shared, they're not being shared evenly. And so what happens is they spend a lot more time with the chlorine than they do with the hydrogen. And so this means that chlorine is going to be partially negative and hydrogen is going to be partially positive because the electrons, which are negative, are spending more time around the chlorine. And so this is where our electrons are shared unequally. And that's the key thing there. It's an unequal sharing. Okay, and you have partial charges. So ionic compound, you have full charge, +1, -1. Here, it's only kind of positive, kind of negative. It's not fully each. Now, a nonpolar covalent bond, like what's found between two chlorine atoms in chlorine gas, if you have two chlorine atoms and the electrons are being shared between them, it's being shared evenly. One chlorine is not stronger than the other. And so this tells us that the electrons are, again, they're shared equally. And this means that there are no charges. So, key thing here, nonpolar electrons are shared equally and they have no charges. Polar is shared unequally and there's partial charges. And in ionic compounds, they transfer the electrons, they do not share, and they have full charges on their electrons. Now, all of this, whether or not it transfers or it's shared unequally or it's shared equally, is all based on an atom's electronegativity. Now, remember, we talked about electronegativity in Unit 3. It was one of our periodic trends. And electronegativity is a measure of an atom's ability to attract an electron, okay? So you can attract an electron in a compound. So how good is it when it's trying to form a bond at attracting the electron to its nucleus? Okay, so for polar covalent bonds, the atom that has a higher electronegativity is going to be, sorry about that. The atom with the higher electronegativity is going to have a partial negative charge. The one with the lower electronegativity value will have a partial positive charge. And so remember, when we're drawing this, it can look one of two ways. For example, HCl, you can have hydrogen, and you can have chlorine, which I'm drawing bigger because chlorine has a larger atomic radius, and its electron density would look like this, where the electrons are spending more time around the chlorine. Okay, so key thing here is that the shared electrons spend more time with the chlorine, or the highest electronegative atom. Okay, so remember, on the periodic table, you have hydrogen on the right side, chlorine on the left, and we know that electronegativity increases as you go to the right. And so that is a pattern that you'll be able to use to help you determine this. So this is, again, just going over the 3 types of bonds. You need to make sure that you understand how the atom, or how the electrons are shared or not shared in a bond when we're comparing all 3. That's going to be crucial to your understanding. Okay, so on the back of your notes, we're going to go into the different ways that you can determine whether or not something has an ionic bond, or a polar covalent bond, or a nonpolar covalent bond. So one of them is by using their electronegativity difference. So remember, electronegativity, which is the ability to attract an electron in a compound. It's a pattern on your periodic table that we learned. There are also like specific values. You never need to have these numbers memorized, but I will provide them for you. So for example, for an ionic bond, okay, the highest electronegative atom, so whichever atom has the highest electronegativity, will form an anion. So that means it gains electrons. Okay, remember that an anion is something with a negative charge. Okay, whatever atom is the least electronegative, or has the lower electronegativity, is going to form a cation. And this means that it will lose the electrons. Remember, cations have positive charges. Remember, cats have pos, so cations are positive. Okay, now our electronegativity trend. When you go across a period, which means from left to right, okay, so left to right, across the period, okay, that means that the electronegativity increases. But when you go down a group or down a column, okay, so you go from the top of the periodic table down, what's going to happen is your electronegativity decreases. And so this means that if you're looking at your periodic table, okay, and it's this little square, your high electronegativity is in the top right, and the bottom left has a low electronegativity value. And this is the pattern that we learned in Unit 3. So the difference in electronegativity, which remember, difference in math just means subtract. So the difference between them determines the type of bond or polarity. Okay, and so we're going to look at this here. Okay, so when you're doing your electronegativity difference, if the difference, there are 2 numbers that you're going to need to memorize, 1.7 and 0.4. If you have something that is higher than 1.7, then that means it will form an ionic bond. If it's between 1.7 and 0.4, that means it will form a polar covalent bond. And if it's less than 0.4 all the way to 0, that means it will form a non-polar covalent bond. Okay, and so this is the difference there. Now, the difference in electronegativity, difference in math means subtract, and it's represented by the Greek letter delta, or this triangle. And so difference in electronegativity is sometimes abbreviated as delta En, or triangle En. Okay, so let's look at some examples. If I have a molecule of Cl2, okay, I'm going to actually list out on the side a couple of electronegativity values that we're going to want to know. So I'm actually going to move this text higher so that we can look at that. All right. So the electronegativity value of chlorine, so we're going to make a little chart over here. You're going to have your atom, and then its electronegativity value. So chlorine has an electronegativity value of 3.0. Hydrogen has an electronegativity value of 2.1. Sodium has an electronegativity value of 0.9. Let's see. Sulfur has an electronegativity value of 2.5. Cesium has an electronegativity value of 0.8. Fluorine has an electronegativity value of 4.0. And we're going to keep our chart going. Oxygen has an electronegativity value of 3.5. Chlorine we've already done, and phosphorus has an electronegativity value of 2.2. Okay, so these are the numbers we're going to use. And again, if I was asking you to do electronegativity difference, I would give you those numbers on like a quiz or test, things like that. So if we have Cl2, so this means that we have a bond that is between two different chlorine atoms. Okay, so this is our bond here. This means that I need to subtract 3.0 for this chlorine minus 3.0 for that chlorine. That gives us 0.0. So my electronegativity difference is 0. And if it's 0, that makes it a nonpolar covalent bond. Now, what if I was looking at HCl? That means this is a bond between hydrogen and chlorine. So we know that chlorine has a higher electronegativity value because it's 3.0, whereas hydrogen's value is only 2.1. So it's always the highest minus the smallest. So that would mean that our delta electronegativity value is 3.0 minus 2.1, which gives us 0.9. 0.9 is between 0.4 and 1.7, so that makes this a polar covalent bond. Now, if we are looking at a bond between sodium chloride, okay, that means sodium and chlorine. So again, chlorine has a value of 3.0, but sodium has a value of 0.9. So that would mean saying 3.0 minus 0.9 gives us 2.1, which clearly is higher than 1.7, so it makes it ionic. And again, all we're doing to figure out those values is comparing our final answer for our delta electronegativity difference against our chart here. Now, when you have these densities, okay, and this electronegativity. Remember, electronegativity, if it's really strong, will pull the electrons, okay? So if we have this nonpolar covalent bond, there's a difference of 0. This is like tug of war. They're equal strength. And so this means that the electron density is symmetrical, meaning it looks the same. They're both pulling on the electrons with equal strength. But with hydrochloric acid, HCl, it's polar covalent. That means the chlorine is stronger. It's got 3.0. Hydrogen is only 2.1. So this means it will pull on the electrons unevenly. Chlorine is stronger, so it'll have an asymmetric electron density. And then for sodium chloride, it's ionic, and so this means that there is the electron density is not really applicable. It's not being shared because there's a complete transfer. So chlorine is so much stronger than sodium that it takes the electron completely away. It does not share at all. And so you can see, depending on who chlorine is bonding with or which other atom it's bonding with, and the power difference determines the type of bond. So what I want you to do is I want you to do this exact same type of calculation, and I want you to do that for these bonds. So if I have a bond being formed between sulfur and hydrogen, okay, which we'll use our numbers off to the left. We look first for the most electronegative atoms. Sulfur is 2.5, hydrogen is 2.1. So sulfur is the most electronegative. And so we know that the electronegativity difference, which that's what this is supposed to be, or delta En, would be 2.5 minus 2.1, which is 0.4. 0.4 is right on the line, and if that's the case, then we would say it's polar covalent. Okay, you always go up. So if it's 0.4, it's polar covalent. If it's 1.7, it's polar covalent. Okay, and so I want you to do that for these other ones, and then press play on the video when you're ready to check your work. Now that you've completed the work, you can check your answers here. And then we are going to just kind of wrap it up and summarize covalent, both nonpolar and polar, and ionic. So this is kind of your summary, the things that you need to make sure you understand. So with a nonpolar covalent bond, you need to remember that electrons are shared equally. This is because they have equal strengths. So that means they have symmetrical electron density. Okay, and it's usually between identical atoms. Okay, so that means that they have the same strength, okay, or the same electronegativity difference, and so the same strength. They're pulling on the electrons equally. Now, with a polar covalent bond, the electrons are shared unequally. And so usually, or this will mean that you'll have an asymmetrical electron density, meaning that the electrons are spending more time around one atom than they are the other. This is going to result in having partial charges. So you're going to see partial positive, partial negative areas. And it's usually between hydrogen and a non-metal of some sort. So hydrogen and chlorine, hydrogen and fluorine, hydrogen and oxygen. Okay, usually those are the types of elements that are involved for a polar covalent bond. In an ionic bond, electrons are transferred. And one thing to keep in mind, that they're transferred from usually your metal to the non-metal. Okay, so your metal is going to form your cation, and your non-metal is going to form your anion. And so this means that your ions are formed, okay, the cation, which is positive, the anion, which is negative. It experiences an electrostatic attraction between the cations and anions, and it's usually between a metal and a non-metal. Now, using these notes, you're going to be able to practice identifying what type of bond will occur and the properties of them. So, if you have any questions, let me know after school or in an email, or you can leave a comment on the video.